You got some papers that are yours right there, buddy.
Thank you.
You're welcome.
I have a great feeling about today.
Okay. Gina loves that for you.
Great.
Okay. What numbers did we do?
8 through 48 evens, but we didn't do 18 through 26.
Oh yeah, we got to finish that lesson today, right? Yeah, I don't think we finished it. We didn't. We omitted some stuff, right?
Well, you just said you were going to do stuff like that.
I said, oh yeah, you're right. You're right. We don't got to finish nothing. I also need to look. Forgot to double check because I was grading papers. Got to look at what I did for this class. Got all my Google Classroom stuff back going. We're sliding back into. We are sliding back into normalcy. Classroom. But as we slide in there, some of the classes, some of the like due dates are a little bit wonky from the way they normally are. Let me see what I did for y'all. Y'all's is relatively normal. Let's see. What notes did I assign? Yeah. Okay, good. That's great. Past me is thinking the same as this morning me. Okay, so we're going to do this, and then we're going to cover in class today inverse functions and relations. And you have notes on 6-3 for Thursday. So we're kind of back into normal notes, homework flow, coming off of storms and other things. Okay, making sense? All right, number 8. F plus g of x is negative 2x plus 5. F minus g of x is 6x minus 5. F times g of x is 8x squared plus 10x. F divided by g of x is 2x over negative 4x plus 5. X cannot be 5/4. Number 10. F plus g of x is x squared minus x plus 1. F minus g of x is x squared plus x minus 1. F times g of x is negative x cubed plus x squared. F divided by g of x is x squared over negative x plus 1. X cannot equal 1. Number 12. F plus g of x is 3x minus 9. F minus g of x is negative x plus 5. F times g of x is 2x squared minus 11x plus 14. F divided by g of x is x minus 2 over 2x minus 7. X cannot equal 7/2. 14. F plus g of x equals x squared plus 3x plus 1. F minus g of x is negative 3x squared minus 3x plus 11. F times g of x equals negative 2x to the 4th minus 3x cubed plus 17x squared plus 18x minus 30. F divided by g of x is negative x squared plus 6 over 2x squared plus 3x minus 5. X cannot equal 1 or negative 5/2. 16. F plus g of x equals 375x plus 10. 16b, f minus g of x equals 2x plus 40. Number 28. F of g of x equals 3x minus 24, and g of f of x equals 3x plus 8. 30. F of g of x equals x squared minus 14. The range is y is greater than greater than or equal to negative 14. G of f of x equals x squared minus 8x plus 6. The range y is greater than or equal to negative 10. The domain on all of these is all real numbers, by the way. Okay, where was I? 32. F of g of x, 32x squared plus 44x plus 16. The range is y is greater than or equal to 0.875. G of f of x equals 8x squared minus 4x plus 7. The range y is greater than or equal to 6.5. 34. F of g of x equals x squared plus 3x squared plus 1. The range y is greater than or equal to 1. G of f of x is x to the fourth plus 6x cubed plus 11x squared plus 6x plus 1. The range y is greater than or equal to 0. 36a, p of x equals 5.75x minus 1,850. 36b, p of 500 equals $1,025. P of 1,000 equals $3,900. P of 5,000 equals $26,900. Number 38. F minus g of x equals x squared minus 9. The domain is all real numbers. 40. F divided by g of x equals x plus 4, and the domain x cannot equal 3. What questions do we have on those? We're doing this. For Thursday?
No, for today.
Assign something for today? What did I assign for today?
6-2.
Oh yeah, homework. Yeah, nice. Luckily for you, this is a review. There's also a video of it on Ember Learning Labs. You can watch if you need to.
I did the same thing. So on Thursday, did you guys do the notes for 6-1?
Oh yeah. Oh yeah. No, see, y'all are weird. Yes, we did. Correct. We did do that. Y'all's day, not y'all are weird. Y'all's days are weird. That's why there's stuff to do like today and tomorrow. It's because I decided to do weirdness now instead of getting the flow flipped to where you have 2 lessons due on Thursdays and 1 on Tuesdays, because I thought that would be more painful than a little bit weirdness now sliding us back into a normal flow. Because if I had done it if I had done it and just done stuff, then y'all would have ended up having 2 lessons on Thursdays, which is a lot between Tuesday and Thursday. So that's why it's a little bit weird. If you have stuff late today, tomorrow, will be counted late as long as it's expedient. We are going to cover some of that stuff today. Making sense? Now that we have logistics and back end, any other questions? We can do 32. 32. Decided to attempt to make that marker do that whole thing. I'm not sure that I succeeded. Whoa. Okay, that says 4x plus 3 for the g of x. All right, so for 32, we are expected to find f of g of x and where'd the magnet go? There is he. Let's do this. It's too thick. Just got to remember that I have this. Stephen, you're here the longest. You have to help me remember that I stuck the magnet to the tripod. Except that's aluminum. Just kidding. I just set it there. Okay. Great. Use lay clippy. Okay, great. Where was I? Oh yeah. F of g of x and g of f of x. Yeah, I said that right. F of g of x and g of f of x. To find f of g of x, what do? You put g inside of f. So in f, everywhere there's a variable, you put parenthesis. And then we put g inside of there. So we're going to put 4x plus 3 right here. 4x plus 3. Oh, by the way, depending on how many questions we have today, we are going to cover inverses in class. If we get through the entire lesson, which we probably will because it's not a difficult concept, you can turn in for your notes what we did in class today, and you don't have to watch the video, but you can watch the video. Does that make sense? All right, so we need to clean this up because he's ugly, so what should we do? Bruh, no, not distribute the squared. We should do the squared. We should do the squared. We can distribute something. What can we distribute? No, not till we deal with the squared. The negative we can distribute. Go ahead and take care of heme, yeah? So this turns into 4x plus 3 times 4x plus 3. What do we do with that? You can do the shortcut, that's fine. A squared, so what's 4x squared? 16x squared. And then what's the next part? Plus 2 times A times B. So what is 4x times 3? 12x times 2, 24. So plus 24x. And then the last part. Oh, I left off the 2. Why didn't y'all tell me? That's crazy. Our equals is just sliding over. What's the last part? B squared. So what's 3 squared? You could also do it the long way and just go pshink, 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 and then combine like terms in the middle and you'll get that, yeah? And then we got to bring down all the rest. So distributing the negative, we've got minus 4x minus 3 plus 1. Now what should we do? Distribute the 2 sounds good. That's a lot of words there, bruv. On super chat. I can't do super chat. I'm not monetized yet. Actually, just kidding. I think I might be at that first level. I don't remember. I might be at the super chat level. Is that a first level little YouTube thing or is that a second level thing? I don't remember. Don't have time to look at it right now. All right. Distribute the 2 sounds lovely. I bet we could do one other thing. What's the one other thing we could do? Find negative 3 and 1 sounds good. So what is 2 times 16x squared? 32x squared. 2 times 24x
48x.
is 48x. And then 2 times 9, 18. Negative 3 plus 1. Negative 2. What else can we do? Combine like terms, we can. Where are they?
It's the 48x and the -4x and the -2.
That is all correct. The 48x and the -4x. And then the 18 and the -2. So f of g of x equals 32x squared. What is 48x minus 4x? 44x. And then what's 18 minus 2? 16. All right. I suspect the next one is going to be shorter, but let's take a look. So to find g of f of x, what do we do? I walked over here to grab this water, and then I left it. What should we do? Well, it's because there's no water in it. That's probably why. This is a simple question. To find g of f of x, what do we do? We put f into g. Right? So we put g with parentheses where the variables are. Right? So this equals 4 times plus 3. And they put all of f inside of there. I don't know if I gave me enough space, but let's see what happens. 2x squared minus x plus 1. Look, Mom, I did it. Now what? Distribute the 4. Indeed. So what's 4 times 2x? It is. Not, but it is what I meant. 8x squared. What is 4 times negative x? Negative 4x, true enough. And 4 times 1, I got it. That's the tricky one. It's 4. Then we combine like terms, right? 4 plus 3 is 7. So g of f of x equals 8x squared minus 4x plus 7. Easy peasy. Okay. What other questions from this lesson do we have? We could do 40, sure. Mmm. 40 adds some interesting flavors, doesn't it? Because I bet your answer was more complicated than what I read, wasn't it? Yeah. Yeah. 40 is a bit tricksy. So it wants us to find f divided by g of x. F of x equals x squared plus x minus 12. And g of x equals x minus 3. This problem is really kind of trying to push us and get us ready for the rest of the chapter. Because we're going to be doing lots of stuff with this. I've said this one before, and I think pretty much I'm preaching to the choir at this moment. I don't know that we're there, that at least most of you are struggling with this. But if you can't factor, please, for the love of yourself and your sanity, go practice factoring, because we are going to do a bunch of it in this unit. So to start, we just put f over g, x squared plus x minus 12 over x minus 3. Now, you probably circled that and moved on with your life, right? But this one, we can do more. What do you think we might could do to clean this one up?
You take out an X and a 3.
No, we can't, because they don't all have all of that. What can we do in the numerator? We probably could. That was what I was just ranting about. So it's probably connected. We could factor it. What does it factor into? 3, 4, minus plus. Okay. So what's going to happen now? What happens to the x minus 3s? No, it doesn't get flipped. We have x minus 3 divided by x minus 3. Turns into 1. It cancels. Which, I'm gonna give you some preview words that you might want to log in the brain there. This thing, when we graph it, he's got a hole. He's got a hole at 3. So f over g of x equals this. But x cannot be 3. If we're going to do it in integral notation like we do for this class, it'd be negative infinity to 3 not included, and then 3 to infinity.
How do you figure out what it can't be?
Set the denominator equal to 0. Right? Because the denominator can't be 0. And then solve that, and you get 3. Easy peasy. Okay. Let's do 6-2. Inverse functions and relations. Yeah, there is a video over this. You can watch the video if you wish. You can also just turn in the notes from today's class as the notes. But if you're like, this was confusing, I need a refresher, go ahead and watch the video. No big deal. Okay. So, what is an inverse function? That is our question numero uno. So to answer that question, let's start by asking a different one. What is a function? No, but you can find a 0 of a function by setting it equal to 0. What is a function? Something with what? So it does have letters in it. What do those letters represent? Unknowns. They're variables. True.
Is it an equation that can be used with sets of numbers?
So you're getting closer. You're getting closer to the truth. So you said a couple things that are important. One of those things that you said was important is spot on. The other one, we're gonna say what you said kind of, but even more generic than what you said. Okay? So the thing that was very important was you said between sets of numbers. right? So a function is a relation. It's a specific kind of relation. A relation is two sets that are connected with a rule. There's a rule that takes and maps this group of numbers onto that group of numbers, right? That's what a function, that's what a relation is. A function says for every member of the domain, what are some of our other words for domain?
X values.
X values, absolutely. What else? How about independent quantity, right? The domain is also the inputs in the system. The absolutely classic example when you're first learning about function is like a peanut butter and jelly sandwich. Inputs into that system are peanut butter, jelly, and bread, right? Those are the inputs. We put those in and we get out sandwich, right? So that's the domain. And so a function is for every member of the domain, it is mapped to one and only one member of the range. What else do we call the range? What are some other names for him?
The Y, or dependent or output.
All true. Y dependent and output. This is all Algebra 1 stuff so far, right? So in a function specifically, for every member of the domain, it matches to only one. Now, you can have more than one thing point to the same thing, but each one of these has to only point to one. That makes it a function. So far, so bueno, right? We learned things like vertical line test, right? If it doesn't touch more than once, it's function, right? All that's true. Okay, so what is an inverse? That is the topic of today. So what is an inverse? So an inverse function or relation, all it does is it takes and swaps the domain and the range. So it takes these and it flips them. And at its core, that's all it is. Okay? Now, it turns out when we're graphing inverses, something interesting happens. Let's do this with a parabola, something that we know how to graph. If I have f of x equals x squared, what is that going to look like?
The parent function.
It is the parent function, right? So it's the parent function parabola, right? So what does it look, what is that, even more details? It does. It's actually a parabola, not a U, but you know. Where does it go through? What are some critical points in that function? 0, 0 is where the vertex is. That's true. 0, 0. Where are some other critical points in that function?
1, 1.
1, 1. True enough. And then the symmetric point on the other side. And then 2, 4, right? Would be on there. 1, 2, 3, 4. All right, so that's what it looks like. To find the inverse algebraically, we do what you would think you do. You take and switch the x and the y and solve for y. Now, this is gonna tax us ever so slightly. Okay. So we rewrite this with a y. And then we switch them, put an x here and a y here. We need to solve that for y. So what do we need to do in order to solve for y? No, that won't solve for y. We got to get y by itself. How do we get rid of the squared? We square root it. True enough. What happens when we take the square root of an equation? We get plus or minus. True enough. Square root. Square root. So y equals plus or minus the square root of x. That is the inverse. Now, the notation for an inverse is, this is f inverse of x. Okay, it's a little -1. Which unfortunately isn't really the same as to the -1, even though it looks like it. Wait till we get to trig, it's even more there. But context gives us what we want, right? Sometimes math is like English. All right? Okay, so let's graph that inverse. Now, I know we haven't recovered radical functions yet. We will, right? So you got to kind of remember, what does a square root graph look like? Does anybody remember? No, it's not. That's a good guess. It's like a sideways parabola. It's like a sideways parabola, but only half of it. It's only half of it, right? So if I put a 1 in here, what's the square root of 1? 1, right? So it's going to go through 1, 1. If I put a 0 in there, what's the square root of 0? 0. Now let's put something else that we know a square root of. So what's the square root of 4? 2. Now, I don't know if you've noticed something about this orange one related to the red one yet or not. If you have, good on you. If not, I'll spell it out more specifically. Now, what is the negative? Like if we do the -1, what is that going to do to the orange graph?
Apply imaginary, right?
No, it would if it was inside.
Would it be on the bottom? Like
Yeah, it just flips vertically, right? It's that same as A. Like on the red one, if we put a negative here, it just takes this and goes boom. Same with the things, right? That's why we learn parent functions, because the rules apply to all of them. The shape just changes, right? So this would be the exact same thing, but down here, right? All right, so we've got this point and this point. Now, this one, it's worth noting, is not a function, right? It fails the vertical line test. But it's still a relation. And it is the inverse of that one. So, algebraically, this is how we do it. We take them, we flip them. But vertically, it's worth understanding what is happening and what has happened. What happens is the inverse on a graph takes and it reflects the original. Now, you might be thinking, well, if it reflected it, wouldn't it be down there? You'd be right if it was reflecting over the x-axis, but that's not what it's reflecting over. Can somebody tell me and make a guess, what do you think it's reflecting over? No, not quadrant. Quadrants is just like the map. So if it was a rotation, it's kind of what you're thinking, but it's actually not a rotation. This one looks like one. But if we had like a cubic one or something, it would look less like a rotation. It is reflecting over the line y equals x. That's exactly what it does. So visually, what happens graphically for an inverse is it reflects over the line y equals x. So if we have something like this, let's make something up. If we have maybe this guy, which is totally something you may have to do pretty soon, right? To find its inverse graphically, it would be down over here, right? So it'd be something, I'm not going to draw it perfectly, obviously, it'd be better with points, but it'd be something like that. Right? So take it and it flips it over that line. Making sense so far? Easy peasy? Good. All right, let's do some various examples. This guy on the internet tried to fight me this morning. It was funny. Why? I didn't fight him because he was mad that I said all of these people in this group needed to calm down and it wasn't that deep. And he told me I had a bleep take. And I decided 3 things. I was not going to actually argue with him because that would have been pointless and only made me angry. So no, I didn't do that. I also decided I wasn't going to be ugly to him. I was not going to say anything rude, no matter what he said. And number 3, I wasn't going to stop talking. No, I don't have to report it. It's fine. No, that's no point in that.
Bravo, Mr. Sean.
I don't know if he's responded to anything else, but, you know, it's funny. It makes me laugh. I'll probably do. What is that? Oh, stupid LHN thing. Go away. All right. Let's find the inverse of this and graph it and its inverse. Let's do these one. So f of x equals x minus 3 over 5. Okay, so we're going to start by finding the inverse of that. Before we do that, I want to, it is, you know, I said something that is useful, and I've said this before. It's important that you kind of start to, as we get into more and more graphs, because that's a good chunk of the rest of this, is different shapes and different graphs. The more we get into this, the more, if you can keep the big ideas in your head, the easier the little minutia will be, right? That's why we learn parent functions, because the patterns are the patterns, and they work the same way, whatever the picture looks like, just with different shapes. So, what shape is that?
Is it a parabola?
That's definitely not a parabola.
Is it because the x isn't squared?
It's because the x isn't squared, that's true. So what shape is it? Because it's just x to the first. It's just a line. It's easy peasy. This is a line. And we know it's a line because it's just x to the first. X isn't down here, or squared, or cubed, or square rooted, or anything else. Or in an exponent. That's a line. So its inverse is going to be a line that's reflected across the line y equals x. Easy peasy. So algebraically, in order to find the inverse, what should we do? No. Put y in for x and x in for y. So we're going to put an x right here, and we're going to put a y right here. Now what should we do?
Multiply times 5.
Yeah, because we're solving for y, right? That's our goal right now. Because now we want to put this in slope-intercept form, right? That's 5 times 5. So we've got 5x equals y minus 3. Now what? Add 3 on both sides. So y equals 5x plus 3. And then it says to graph that one and its inverse. So this is f inverse x, right? The original, this is a little bit tricksy. You may want to split it up on your paper. On the original, what is the y-intercept of the original? Negative 3/5. That 5 goes into everything, right? So it's like right here-ish. Right? What's the slope of the original?
-3/5.
Come on, kids. F of x equals x over 5 negative 3/5. What's the slope? 1/5. So up 1, right there-ish, over 1, 2, 3, 4, 5, right? So about like that. So if we did it correctly, this line, in order to get to that line, should reflect over this line, right? We can dot this line in and take a look at it, see whether it looks like we did good or we failed, right? So to flip over this line, right, this is going to kind of go, this part's going to go up here and this part's going to go down there, right? So let's see. What's the y-intercept of our inverse line? 3. True enough. And what is the slope of our inverse line? 5. 5 over 1. I'm going to, because of the way my graph, I'm going to go down 5 and back 1. Because negative over negative is positive, right? I could go up 5 and count over, but it's going to hit in a better place if I flip them both. 1, 2, 3, 4, 5, back 1. And then I'm going to connect my dots. If we flip over, we get it. As close as my not well-scaled picture can get, right? Making sense? Easy peasy so far. Good. Let me see what numbers I gave y'all. I'm trying to see if I can let y'all go a little early to start work on your homework since it's due at a weird, since it's all kind of due weirdly. That would be nice. Let me look. 2 through 48, is that what you wrote down for 6-2?
I think. It's either 2 through 40 or 2 through 48.
2 through, you sure it's not 38?
Is it 30?
Let me see. Due tomorrow. 2 through 38.
Okay. I was like, it's
Okay. Yeah, there's one more thing that I need to teach you, and then I will let you go. That is questions where it says, are these two functions inverses of each other? If a function, two functions are inverses of each other, then f of g of x is the same as g of f of x, and they both equal x. Okay. So, doing one example, let's do the more ugly one. Let's find out whether f of x equals 2x squared minus 1, and g of x equals the square root of x plus 1 over 2. Let's find out whether those are or are not inverses. So in order to do that, we have to find f of g of x and g of f of x. All right, so for f of g of x, we're going to take g and put it inside of f. So 2 with a parenthesis, squared minus 1. Inside the parenthesis, square root of x plus 1 over 2. What do we do to clean that up?
You cancel the square root because
Square root cancel, you're right. So it'd be 2 times x plus 1 divided by 2 minus 1. Now what? The 2 and the 2 cancel, top and bottom. So we've got x plus 1 minus 1. Now what? Plus 1 minus 1 cancels. So we've got x. So far so good, but we've got to we have to check g of f of x. G of f of x equals, I'm going to put f inside of g, right? So the square root of parentheses plus 1 over 2. Put f inside, 2x squared minus 1. Not yet, because it's not this whole thing squared. Nope. Don't deal with the square root thing yet. Got to deal with what's inside. Is there anything in front of the parentheses? No. So he don't matter, right? So he can just drop. So what's going to happen now? Negative 1 plus 1 turns into 0. Additive inverse. So square root of 2x squared over 2. Now what? No, not yet. 2 divided by 2 is what? 1. So we've got the square root of x squared. Square root and square root cancel, leaving us with x. So this works. So yes, they are inverses. All right. I think y'all can leave. Let me double check. But I think we are good to go. We are good to go. See y'all Thursday. You just switch the x's and the y's.
you just flip everything.
Yeah.
Okay.
Oh. Super chat, super chat, super chat. Okay. I have to go look to see whether that's unlocked on my account.